See, when we studied about polynomials, we studied about linear polynomials, right?
Yes, sir. Yes, sir.
That means, what is a linear polynomial? A polynomial whose degree is what?
1, sir.
1.
Yes, any polynomial with a degree 1 is called a linear polynomial. For example, if I write x plus 5, this is a linear polynomial, correct? This is an example of linear.
Yes, sir.
Okay, linear polynomial. And we know that if I just write like x plus 5, you also call it as expression or algebraic expression, right? It is called an expression. But same expression, if I take the same x plus 5 and I put equal to something. X plus 5 is equal to something. So let's say it's very simple. I'm going to put equal to 0. Now what this has become?
Equations.
Now it has become an equation. And because it was a linear polynomial, it has a degree 1. So this will be called a linear equation. Okay. As long as the equation has highest power of the variable as 1, that is a degree 1, then it will be called a linear equation. But the thing is, we are going to not study just linear equation, we are going to study pair of linear equations. So there are going to be 2 linear equations, and that too not only in one single variable, but in 2 variables. So all these examples, the example which we saw so far, x plus 5, this is a linear equation in one variable, right? Can anyone give me an example of a linear equation in 2 variables?
Sir, x plus 10 is equal to 1.
X plus 10 is equal to
1.
1.
Sir, but it is having only one variable, no?
Yes, still it has only one variable x. So this is a linear equation, but it is in one variable only. So I'm looking for an example of linear equation in 2 variables. So what should I do?
X plus y is equal to
X plus y is equal to
any number.
any number, let's say 5.
Sir, 5x plus 2y is equal to 0.
Okay, excellent. So these are examples of linear equations in 2 variables.
In 2 variables.
Okay, so before we start studying about linear equation in 2 variables and we go to the pair of linear equation in 2 variables, let me just establish something ground rule about the linear equation in 2 variables. So if I have a linear equation in 2 variables, it has to have some standard form. Some of you will be familiar with the word standard form of an equation. Do you know about that? So you people gave me an example like this: x plus y is equal to 5, or 5x plus 2y is equal to 0. I can write more examples like 3x minus 7y plus 4 is equal to 0. This is also a linear equation in 2 variable, correct? So I want to write a standard form, which using which we can represent all the linear equation in 2 variables. So anyone has any idea? Can anyone tell me?
ax plus by is equal to 0.
Okay, ax plus by is equal to 0. What do you people think, guys? This is very close. But you see, when I wrote this kind of a polynomial, ax, it follows by, that is also okay, but equal to 0. Does it always have to be equal to 0? No. For it to be a linear equation in 2 variable, I can have any other constant also. So let's call it as c. Okay. But this is one way of writing this linear equation in 2 variable. Or the better way to write this is keep everything in one side. Ax plus by plus c is equal to 0. This is the other way of writing the same standard equation, standard form of the linear equation in 2 variables. and this is the one which I will be using from now on. This will be the standard equation. So remember, both of them can qualify as the standard form, but I'm going to use this one, where I have got the C to the left hand side itself. So now let me give you some examples of linear polynomial, linear equation into variables, and you will tell me how do you relate it with this standard form. Okay, let's say if I say 2x plus 3y minus 7 is equal to 0. Look at this and look at the standard form. Do they look very similar?
Yes, sir.
Yes, they do. Okay, and then using this from this equation, can you tell me what will be the corresponding value? What is the coefficient of x here? What is a here?
2, sir.
2,
A is 2. Very
2.
good. What is b?
3,
3,
C.
And what is c?
Minus
minus
7.
7.
Yes, you should consider the sign also together. So it should be minus 7. Okay. So a, b, c we can figure out from here. So this is a standard form of linear equation in two variables. I can give you more examples. Let's say if I write okay, so if I write like this, do you see that this is also similar to this form? Or is there any problem? Does it look like the standard form?
Yes, sir.
Yes, it is of the standard form, but the only thing is the constant is on the right hand side. So what we will do, like I said, I'm going to use it this form always. So I don't want my constant to be on the right hand side. So you bring it to the left hand side, transpose it to the left hand side. So what I can write x by 2 minus 3x. When 4 comes to this side, it will become minus 4 is equal to 0. So now it completely follows the standard form of the equation. Okay, so whenever you need to decide what are the coefficients like a, b, c, you should always do this transformation. You should bring it to the left hand side, and all the things should be on the LHS, and RHS should be equal to 0. Then you should decide on what is my a, b, and c. So now for this equation, tell me what is a, b, c here, guys. What's a here? What is the coefficient of x?
1 by 2.
Yes, the 2 is in the denominator. It means actually it is
2.
1 by 2. Okay, it's 1 by 2. So coefficient of b should be easy. Tell me what is b?
Minus
3.
minus 3.
3. Minus
See,
3.
yeah, negative sign also we need to consider. Okay, so it's b minus 3. What about c?
Yes, minus 2.
Minus 4.
Minus 4.
Minus 4. It's very important because if you had not done this transformation, you would have written c is equal to minus 4. So that would have given you trouble. Okay, so you would not do that. So that is why what I'm going to do, even though in some books it will be written like this, so I'm going to remove this from here. You need to know that it can be written that way, but consider only this as the standard form. Okay, so from now on, this will be the only standard form for linear equation in two variables. So you have to bring c to the left hand side, and then you will decide whether it's positive or negative. Okay. Okay, so now since I have told you that a, b, c are some constants over there, let me give you some more consolidated rule about what a can be, what b can be, and what c can be. Okay, what is a, b, c over there basically? In the standard form of linear equation in two variable, that is ax plus b.
Constants.
Yes, ax plus by plus c is equal to 0, where a, b, and c are some real numbers. Constants means they could be any integer, rational number, irrational number. We don't care anything. They have to be some real number. Okay. But when I'm saying all that, what if A and B both are equal to 0? What will happen? A is also 0 and B is also 0. Then I will have only 5 is equal to 0 as an example. So does it still qualify as a linear equation in two variable?
No, sir.
No, sir.
No,
Yeah.
sir.
So there is a problem. I need to do something about it. I need to specify whenever I'm writing the standard linear equation in two variable in this standard form, I should tell that A and B both cannot be 0. So any one of them can be 0. I can write 5x plus 3 is equal to 0. Still, I can qualify this as a linear equation in two variables. I can say that, let's say I have 5x and the coefficient of y is 0. So 0 times of y plus 3 is equal to 0. Okay. Tell me, guys, do you people understand? If I go too fast, you need to let me know. You tell me, you stop me. Okay. If I go too slow, still you let me know. So 5x plus 3, I'm telling it is a linear equation. It is in one variable, but it can be used in places where we have to use linear equation in two variables also. Okay, I can say that the coefficient of y is 0. So this is okay. This is allowed. This is qualified. Be called compared or solved with a linear equation in two variables. Okay, but I can't have both the coefficients 0. I can't have 0 into x and 0 into y. So that would totally defeat the purpose. It will become a constant polynomial, or that doesn't work. I cannot have just some number equal to 0. No? So A and B both should not be 0. Now there is a way to write this mathematically. Normally you would not want to write all this story in the in mathematics. There is a way to write it. How do you say that A and B both cannot be 0? One of them can be 0, but both should not be 0. Anyone knows how to write that mathematically? For example, I'm saying that if I don't want A to be 0, A cannot be 0 means I write A not equal to 0. If I say B cannot be 0, then I say B not equal to 0. But I want to mathematically write like this. I want to write it like one of them can be 0, but both should not be 0. It's like a puzzle. Think, how would you represent that mathematically? This idea that one of them can be 0, but both of them should not be 0. Okay, so if you cannot figure out, I will give you the solution right away, but I want you to think about it in home and figure out why this works out. Okay, the mathematical representation of that would be a square plus b square cannot be equal to 0. This is a way of telling that both a and b cannot be 0, but one of them is allowed to be 0. So you will try to understand this in your home. Spend some time on it and try to see why a square plus b square not equal to 0 conveys the same meaning what I have written in this box over here. Okay, this and this are exactly same. So make it clearly, a square plus b square not equal to 0. Okay, so you think about it. All right, so far I have written only the representation of linear equation in one variable or two variable, I mean, but I have still not told you about the pair of linear equation. Means now we need to have two such equations. Like for example, I can have 3x plus 5y minus 2 is equal to 0. Let's say this is the first equation. And then I need to have one more because I need a pair. So I can have another equation like 7x minus 3y plus 4 is equal to 0. So now these two together, they become a pair of linear equation in two variables. Okay. Everyone understands what is it that we are going to learn in this chapter? We're going to learn pair of linear equation in two variables. And what about these? What are we going to learn? We are going to learn a few, the topics which we are going to learn. Let me summarize all that, the topics which we are going to see. We are going to learn how to graphically represent all this. Okay. We are going to learn how to find solution of pair of linear equation in two variables. And I will explain what it means to say the solution. What is the solution of these two? If I say that these are the two linear equation in two variables, it has a solution. It may have a solution. It may not have a solution also. That kind of case is also possible, that it may not have any solution. But if it has a solution, how to find it? So there are two ways to do it. One is the graphical method, and one is algebraic method. So both we are going to learn. By graphical method and then by so graphical method means what? By we will draw some graphs on the graph sheet, and using that we will be able to find whether it has a solution or not. If it has, how many solutions it has, and what exactly is the solution of this these pair of linear equations. So that is graphical. Now when I say algebraic, we are going to do some calculations, algebraic calculations. Using that we will find the solution. So in the algebraic method, we are going to learn two types. I'm just giving you a summary of what all things we are going to do. So in this algebraic method, you will learn there is a method called substitution method. Substitution method of what? Substitution method of finding the solution of linear equation in two variables. And then there is one more method called elimination method. Okay. And then there is another method called cross multiplication method. So using any of these three methods, we can find the solution. So what are the total number of ways? One way is graphical method. And then these are three methods using which we can find solution of any of the pair of linear equations in two variables. And once we have learned all these methods to find the solution, then we will work on some real life situations where this kind of why are we learning all this basically? What is the need of learning this? How to apply this knowledge in real life to solve some real problems? So basically we'll be working on some word problems. Word problems which can be converted to a pair of converted or transformed into a pair of linear equations in two variables. All right. So do you people have a high level idea what we are going to learn?
Yes, sir.
Okay.
Yes, sir.
Okay. So I don't want to start going deep into this right away. So today what I will do, let's just try to understand a few things which you should already know, by the way. So what you studied in your ninth standard? In class 9 also you studied about linear equation in two variables, right? You learned how to draw the graph of linear equation in two variables. Is that correct?
Yes, sir.
So if somebody gave you an equation like 3x plus 4y minus, let's say 12 is equal to 0, will you be able to draw the graph of this one? How many of you remember how to do this?
Yes, sir, by giving values for x and y.
Yes, we can pick.
Substituting one by one
Yes,
values of x.
yes, very good. We can make a table like this, x and y values, put some value of x and then find the corresponding value of y. Correct? So for example, and one more thing, what kind of graph do you think you will get when you put it on the graph paper?
A straight line.
Yes, it is a linear equation. And remember, a linear equation always has a straight line. No matter whether it is in one variable, two variable, or 100 variable, a linear equation always has a straight line graph. So graph of a linear equation is always a straight line. Now, if I want to draw a straight line on the graph paper, I just need 2 points, right? If I know any 2 points on that line, I will be able to take a scale and join them, correct? So knowing 2 points on the graph paper is enough. So that's why we are going to find only 2 points as of now. So let's say first point, I'm going to put the x value as 0. So when x equal to 0, can you tell me what will be the value of y over here for this equation? If I put x equal to 0, what happens to y? What is y?
3, sir.
3 into 0 plus 4y minus 12 is equal to 0. So of course this term became 0. So 4y is equal to 12. So y is equal to 3. Yes, Manoj, you're right. Y is equal to 3. So when x equal to 0, y is equal to 3. So 0 comma 3, this is the first point on the graph sheet. On the xy plane, I can go to 0 comma 3 and put that point over there. So where will be 0 comma 3? On x-axis it is 0, so you don't have to go left or right. That means it will be on the y-axis, and 3 means, let's say this is 3. So this will be your 0 comma 3. So this is your y-axis, this is your x-axis. Okay, what else? This time I will put y equal to 0. Let's say if I put y equal to 0, what do we get? What is the x value, corresponding x value? Tell me.
4, sir.
Yes. So this term becomes 0. So 3x is equal to 12. So x will be equal to 4. So when y is equal to 0, that time x becomes 4. So 4 comma 0 is another point on this line. So where is 4? This is 1, 2, 3, and 4. So 4 comma 0 is over here. So if I know these 2 points, now I can take a scale and join these two and get the straight line. Okay, think of that as a straight line. So this line is what? It's the graph of this particular linear equation in two variables. 3x plus 4y minus 12. Okay, so every point on this line is a solution for this given equation. Every point on the line is a solution for this one equation, 3x plus 4y minus 12. So if I have only one single equation, how many solutions do you think it has?
Infinite number of solutions.
Okay, so if there is only one equation, remember, don't confuse with pair of linear equations. I'm not talking about pair of linear equation in two variables right now. If there is only one single equation, one linear, let me write it down for you as a note, okay, so you remember. If I have a single linear equation in two variable, it has infinite solutions. And what is that solution? Each point on the graph of the equation is the solution of that. Is a solution. Okay. So one single equation has infinite solutions. Every point on the graph is a solution. Now, how many ways are there to find those solutions? See, first I found these two solutions, 0, 3 and 4, 0. These two solutions I found using calculation by algebraic method, by doing some calculation. Okay. And once you find the graph, now graphically also I can find other solutions. What I can do, I can see this point over here and this point over here. Wherever they meet, this point is a solution. So I can figure out what is the coordinate of that point, what is the x value here, and what is the y value here. And you can see that, say that that is also a solution for this equation. Okay. But here my graph is of course not perfect. So 2, it may seem that it is 2, 2, but it will not be the solution over here. Just a second, guys. Okay, so graphically we can find the solution. Okay, now since I told you about this one given equation, I don't want to stop there. I just want to give you a little bit idea that what happens when there are two equations. Would it still have infinite solution? So this time I'm not going to write any equations to keep it simple. Let me just draw the graph. Okay, let's say this is your y. Y-axis, and then I need to have an x-axis also. So that is our x-axis. Okay. Okay. So if I have one given equation, let's say That equation is written here. And there is another equation. What equation I'm talking about? I'm talking about linear equation in two variables. So both these equations, when you plot them on the graph, they will be straight lines, correct? They're going to be straight lines. This is going to be one straight line. This is going to be another straight line. Now, there is a possibility that those two straight lines will meet like this at some point. So let's say this is a graph of the equation 1. Let me write it as. And this is your equation 2. So there is a possibility, right? They will meet at some point. Can they meet at two different points? Any two straight lines, can they meet at 2 points? Is it possible? Is it possible for a straight line, two different straight lines
No, sir.
No,
to
sir.
meet at 2 points? No, right? If they meet, they can meet only at 1 point. Or there is one more possibility that both those lines, they exactly coincide on each other. What I mean to say is both the graphs of both the equations are, let's say, something like say this green line is one equation, and then equation 1 and the other one also is exactly going on the same line. So both these lines, they can sit on top of each other. There is a possibility under certain conditions. If there is a certain value of a, b, and c, both the equations can sit on top of each other. In that case, what will happen? So there is a green line below that. Let's say that is your equation 1. And the yellow one above that, that is your equation 2. So in this case, what is happening? Each point on, they are lying on top of each other. This is another possibility. Okay, so let me not confuse you with these, both the things in the same paper, same graph. This was one condition when they meet at one place. Other possibility is that both the lines are sitting on top of each other. Okay. Can anyone tell me what is the third possibility? There are only 3 possibilities. What is the third possibility when I draw 2 different lines on this paper?
They go parallel and they never meet, sir.
Absolutely, very good. So the third condition possible is they go parallel and they never meet at all. So in the whole universe, there are only 3 possible cases like that. Now those parallel lines could be like this, or any other way. Depending on the equation, the direction will be different. But the idea is that what I'm trying to say is they will be parallel and they will not meet. It's not like this, they will be actually parallel. Think that these 2 lines are parallel. So let's say this is equation 1 and this is your equation 2. So since I told you that when there is only one given equation, it has infinite solution. Now, when you have a pair of equations, there are 3 possible conditions. So what do you think in this case? In this case 1, how many solutions do you think it will have? If the graphs are like this, they meet at one place, Simple, right? It will have the pair of linear equations will have one solution. So let me write that down. These pair of linear equation in they have only one single solution. And where is that solution? It is the solution where the lines meet. This point, whatever is the x coordinate and y coordinate, the x value and the y value, that will be the solution of these two equations. In this case too, how many solutions?
Infinite.
Yes, excellent. It has infinite solutions. In and finite separately, so let me. So it has infinite solutions. And each point on these lines, because both of them have same points will lie on each other. So all of them are the solutions. And what about this case 3?
No solutions.
Yes, excellent. This will have no solutions. Okay. So now, if it has solution, either it can be one solution or infinite solution. There are only two possibilities. It cannot have 2, 3, or 4 solutions. Okay, either only one solution or infinite solution. Otherwise, it has no solution at all. Okay, so that's enough for today. Just make sure all of you go through this video and revise and remember whatever I have taught today.